In this video, I'd like to go over this example. A patient needs to receive 20 milligrams of medication for every 1 kilogram that she weighs. Use this ratio in your knowledge of proportional relationships to calculate the number of milligrams the patient should receive if she weighs 45 kilograms. We're going to use our knowledge of proportional relationships to address this problem. Specifically, I'm going to address it in two different ways. One, looking at the invariant relationship between equivalent ratios, and then we're going to look at the covarying nature. So we're actually looking at two really important properties of equivalent ratios. So first of all, I am told that the patient needs to receive 20 milligrams of medication for every 1 kilogram. That's a ratio. 20 milligrams of medication per or for every 1 kilogram that she weighs. Now we know that this relationship needs to stay the same throughout all other equivalent ratios. So we know if we're looking at another ratio of milligrams over kilograms, it needs to reduce to 20 over 1. So that's exactly what I'm looking for. I'm looking for another ratio, milligrams over kilograms, and we need to compare this ratio to another ratio of milligrams over kilograms. When we talk about the invariance, or in an invariant nature here relationship between these two quantities, milligrams and kilograms, we're looking at each individual ratio. I can see just by looking at this that if I were to take the kilograms and multiply it by 20, that would give me the number of milligrams. That should be clear. 1 times 20 equals 20. I also see, and this is just the inverse of multiplication, if I take 20 milligrams and I divide it by 20 divided by 20, that gives me the kilograms. This here, this kilograms times 20 equal to milligrams, this is the relationship that needs to happen for all other equivalent ratios. This is that invariant multiplicative relationship between these two quantities. So that means my kilograms over here, if I'm looking at an equivalent ratio, I should be able to take that and multiply it by 20 to get the milligrams. And I should be able to take the milligrams and divide it by 20 to get the appropriate amount of kilograms that this patient weighs. Again, this is the ratio just looking at this invariant property. Looking at this problem up top, I see that this particular patient weighs 45 kilograms. So that value is going to go right here, 45 kilograms. Now, if we are looking at an equivalent ratio, I need to take that 45 and I need to multiply that by 20. That's the only value that will go here, right? This is the only value that will be correct if we plug it in here, if we need it to have this same relationship. So 45 times 20 is going to give me 900. That means this patient needs to receive 900 milligrams. Looking at that just one more time, I'm looking for an equivalent ratio that is equivalent to the ratio of 20 over 1. Well, I can see that the kilograms times 20 gives me the amount of milligrams. I need to have that same times 20 divided by 20 relationship between this ratio as well. So since the patient weighed 45 kilograms, I can multiply it by 20 and get 900 milligrams. Now I'm just going to draw a line here. I apologize if this is getting a little out of control over here. Once again, I'm going to start with this idea that the patient needs to receive 20 milligrams for every 1 kilogram that she weighs. When we're talking about covariation between equivalent ratios, again, I'm still looking at another ratio of milligrams over kilograms. But now what I want to do is to look within the same, what we would maybe say, measure space. In other words, I know the patient weighs 45 kilograms. I just don't know how many milligrams she needs to receive. What I know about equivalent ratios is there needs to be the same factor, multiplicative factor, across the ratio. So if I look here, 1 kilogram going over to 45 kilograms, it looks like I'm multiplying 1 times 45 to get 45. I'm looking for that multiplicative factor. And I know if these ratios are equivalent, that same factor needs to hold for the number of milligrams. So if I want this ratio to be equivalent to 20 over 1, I also need to multiply by 45. And again, you'll notice you'll get the same value, 20. I'm going to multiply it times that factor of 45. And that's going to give me my 900. So once again, I get 900 milligrams. I see that this ratio of 900 milligrams over 45 kilograms is equivalent to that of 20 over 1. The purpose of this video, again, was just to look at how we can use these properties, the invariant property and covariant property of equivalent ratios, to solve problems.